Good morning, good afternoon, everyone.
Afternoon, sir.
Good afternoon, sir.
I will ask you immediately to mute yourselves. The bottom
Yes, sir.
left-hand corner has got an icon there. Make sure it's crossed. Please do that. Because each time you talk, there are 200 people here who are listening to what you are saying. Amida, can you please mute yourself? All right, I'm going to assume that you are all muted yourself. And if the same person keeps coming on, I'll have no alternative but to remove the person from the class, because we don't want anybody to cause a disturbance. All right, so welcome to the class. Pearl, can you please mute yourself? Pearl Nguasa, please mute yourself. Welcome to the first session of the senior training program. This is run by South African Maths Foundation, and I'm very happy to welcome amongst us David Ramaboka, who is the coordinator for this program. I want to thank him for inviting all of you, and he's going to be with us for a while. There are some house rules. There is a large number of students. We've got 240 people in this class. And even if one person speaks and if you are unmuted, then everybody hears, and it's a great disturbance. So please unmute yourself and refrain from talking. Close the door in which you are, in the room in which you are, and don't allow anybody to come in and disturb the class. But immediately unmute yourself. If this goes on, then I'll have no alternative but to take you out of the class, to remove you from that, and I don't want to do that. Okay. So if we want to go straight to the problems, today we are going to do, I'll just give you the program. The program is for the next 4 weeks, is that for each of these 4 weeks, we will be doing a different year. The round 2 problems for each of the years 2018 to 2021, over those 4 years, we will go over those problems, and each set has got 25 problems, which means that we don't have too much of time to do the problems in this period, in the 2 hours. So you'll have to bear with me because I will have to go pretty briskly. And I am asking you to mute yourselves, and I'm muting all from my side also, so that there will be no communication between you and me. But what we will do is at the end of the class, as soon as we finish the 25 problems, I will entertain questions from any one of you, either through the chat column, or you can ask the questions directly, but it will be only at the end of the class. During the class, please don't raise your hands, because that also causes a disturbance. So I want to just emphasize, don't raise your hands, and please mute yourself so that we can proceed without any interruption. Okay, I hope you all understand that, and I hope you appreciate the reason why I'm saying that. It's not because I want to be unpleasant, but because I want to protect the interests of the rest of the class. Okay, so we are going to go straight away into the 2018 round 2, the senior training program. And the first few problems are, I'm not going to do this first one, for instance. Everybody can do that. The answer is 820. So please, if you've got a pen and paper, you can just write down the answer and you can check it later. The second problem also is very easy. The answer is 12. write down problem 2, the answer is 12. You can check it later. I'm not going to spend time on these warm-up problems. The same thing with problem 3, the answer is 9. I won't even read the question. I'll give you the answer. You can read it and do it yourself. Okay, problem number 4. Here, again, this is quite easy. I'm not going to spend time over it. I've got the answer at the bottom. It's 1 plus 2 plus 4 plus 8 plus 16. That is how you do this problem. And the answer there is 31. So this is problem number 4. The session will be recorded and put in Google Classroom. So you will have a chance to see it again. We'll see the recording. So don't be too perturbed if you are missing some things. You can always go back to the recording and confirm. Okay, now we're going to start with problem number 5. So problem number 5 says the following. A square and a circle have equal perimeters. If the area of the square is 13 pi, what is the area of the circle? So let's analyze this. There is still somebody who's got the microphone on. Can you please see that the mic at the bottom left of the screen has been taken off? Okay, and please don't raise your hands. Mohammed, can you please put your hand down? The perimeter is the length of the boundary. So the square and the circle have equal perimeters. So let's say that the square, the circle has got radius r and the square has got side s. And we are given that the length of the boundaries are the same. And they tell you what the area of the square is. Okay. And there's the square. We are saying, we are giving symbols to these names. The side of the square, we'll call it S. We don't know what that is. And to find the area of the circle, you need to know the radius. So we'll give a name to the radius. So we actually need to calculate the area. So I've got down here, the area is pi r squared. All right. So that is what we need to calculate. Okay, so let's look at what the given information. The perimeter of the circle is just the circumference. So the circumference of a circle, the formula for that is 2 pi times the radius. And the perimeter of the square is the sum of the boundaries, and there are 4 s's. So if you go through all the boundaries, you'll get 4s. So you have this equation that the 2 pi r is equal to 4s. And now we are also given the area of the square. Now the area of the square is side squared, s squared. Right? And that is given as 13 pi. So these are the pieces of information that are given. And the problem is to calculate pi r squared. So how does one do that? You've got 2 equations and you need to calculate pi r squared. Okay, you're gonna pi r here, there's no r here. So to get the r squared, you have to square on both sides to get a square here. So let's square this to get the r squared in here. So if you square the first equation, 2 squared, pi squared, r squared equals 4s squared, which is 16, 4 times 4, 4 squared, s squared. All right, so I've got my r squared. I need pi r squared. We also have that s squared is equal to 13 pi. So we can substitute for s squared here, and you'll get that that this is equal to 13, sorry, it's 16 multiplied by 13 pi. There is still somebody who's got the mic on. I'm going to ask for the last time, if you got your mic on, please take it off. And I'm going to go to the screen just now and see who has got it on, and I'm going to remove you from the class. Right? This is the last time I am going to make that request, because the sounds you're making with your paper is disturbing the rest of the class. Please ensure that your mic is off. I'm going to go back to the screen just now, and all those people who have got the mics on, I'm going to remove them from the class. I have no alternative. Okay, now you got 4 pi squared r squared is equal to 16 times 13 pi. So the pi's will cancel. One of the pi's will cancel here. And you'll see on the left-hand side, you actually got pi r squared. And that is what we want. So we can look at pi r squared straight away. That is equal to 16 times 13. The pi is canceled here. Divided by 4. Because 4 pi r squared is equal to this. And then we don't multiply, we don't know, calculators are not allowed in Olympiads. So you have to use, you have to cancel fractions. 4 goes into 16 4 times. 4 times 13 is 52. Right? So that is the way we normally work out to work big numbers. We write it as a fraction and we cancel like terms. And that way you can simplify the calculation considerably. So the answer to this problem is 52. Okay, let's get on to problem number 6. Problem number 6. Listen very carefully, because I'm going to do this in a certain way, and you have to understand this. A child's age, when increased by 3 years, gives a perfect square. Now let's try to understand that. It means that if I raise the child's age by 3, I get a square number. Okay, now we're going to give a name to the square number. The square number, we're going to write it as n squared. It's a square number. So what is the child's age? When you increase it by 3, you get n squared. So the child's age would have been n squared minus 3, right? Because when you increase the child's age by 3, you get this. So you let the child's age be n squared minus 3. Now, when you decrease the child's age by 3 years, so you decrease the age by 3 means you're subtracting 3 from it. That gives the square root of this perfect square. Okay, our perfect square was n squared, so the square root of that is n. So you have an equation, right? When you decrease the age by 3 years, when you decrease it by 3 years, that is equal to, it gives the square root of the perfect square, which we called n squared. So the perfect square root of that is n. And now you have a quadratic equation. And you bring all the numbers to one side, and you can solve for this, factorize. I'm not going to spend time on all this. These are calculations. It's got 2 answers, but we're going to say n is equal to 3. Because and we want n squared minus 3. So the age is 3 squared minus 3, which is 9 minus 3, which is 6. So the answer to the problem is the child's age is 6. You cannot use n equals -2 because the age is going to be positive. All right. So that's the answer to this question. And here you see we are taking the information we are using a symbol for the unknown quantity, but I'm using this symbol for the perfect square. So that I don't get too many unknowns. And then after that, you interpret the question and you get an equation. The important thing is the moment you get an equation, then you can solve. A lot of mathematics means that you must try to come to the equation, try to arrive at the equation. And after that, your school mathematics will help you to solve the problem. Okay, how to solve equations. So let's get on to the next question. We're now at problem 7. A triangle has area 800. If the base of this triangle is increased by 10%, then the altitude to this base and the altitude to this base is also increased by 10%. What is the area of the resulting triangle? So the given area is 10%. So we're going to draw the area of the triangle. So I'll draw a triangle, right? It says that if I increase the base, the original area, the area of this triangle, if I know if I give the name to the base, I call it B, and if I call the height H, then we know the formula for the area of the triangle. The original area is half base times height. So it's half B H, right? That's half base times height. Now, it is said that if you increase the base by 10%, so what does that mean? When you increase the base by 10%, it means you're finding 110% of B. Right. So the new base is 110 over 100. That's base is increased by. And the new height is also increased by 10%. So this is a new base and this is a new height. It says that the area the original area, by the way, is 800. It was given that the area of this triangle is 800. So this half BH is equal to 800. So what is this? This is 121 . So the new area is a half of the new base times the new height. So it's a half of, now this is just 11 over 10. You cancel these things. And you get 121 over 100 times BH. BH, 11 times 11. So here you see I've got half BH. So let me put those things together, the half BH. The reason for that is I know what half BH is. So I can substitute, that's the original area. So it's 121% of the original area. This is how you read this. And that, no calculator is allowed. So it's just simply 121 times 8. And you work that out, you get 968. So the answer to this problem is 968. The original area is 800. The new area is 121% of the old area. And when you calculate that, you get 968. Okay, the first few problems I can go quite briskly because when we come towards the latter part, we're going to take a long time because those are much more demanding problems. Okay, the problem 8. What is the sum of all the integers between 50 and 150 that end in 1? So let's just analyze this question first. So what are the numbers between 50 and 150 that end in 1? Right? They are 51, 61, 71, 81, and so on. Sorry. Going all the way, the last one is 141 because you're not allowed to exceed 150. And the question is, what is the sum? So you're going to add these numbers. You can list the entire lot of numbers if you want, but I'm just going to put dot, dot, dot like this, right? And you can add this, right? You can add it by and. It will take a little while, but you'll get to some answer. But the easier way of doing this is to use the formula for the sum of n terms of an arithmetic sequence. Okay. Now, if you know the first term and the last term, there is a formula. Okay, I'm going to assume you know the formula because you are senior students. So the sum of n terms one of the formulas, if you know the first term and the last term, one of the formulas says it's n over 2, where n is the number of terms, right, multiplied by the first term plus the last term, which I like to read as the number of terms multiplied by the average of the first term and the last term. This part here can be written as 51 plus 141 over 2, which is the average of the first term and the last term. So the answer to this is, when you work this out, you get 96 times n. Now we don't know what n is. N is the number of terms. Well, you can count how many terms there are, 5, 6, 7, 8, 9, and go all the way up to 14, and you will see that n is 10. And you can count all these terms if you want. So you got 5, 6, 8, 5, 6, 7, 8, and so on. You can go up to 14, and you see n is 10. Now, while I'm here, here's a useful thing. If you got consecutive numbers, suppose you got 217, 218, 219, going all the way up to some number, 836. And you want to know how many numbers there are in consecutive numbers, right? Then there's an easy way of doing it. The number of numbers here, you might think it is 836 minus 217, but that is not the case. It is 836 minus 216, right? It's one less than this. I'm not going to go into the details of this, but remember, if you've got consecutive numbers, it's the last term minus the one just before this. And that will give you the number of terms. This is the number of terms. So here, if you're looking at 5, 6, 7 up to 14, then it's 14 minus 4, which gives you 10. See, that is where the 10 is coming from. Otherwise, you can just count them. All right, let's get on to the next problem. So here you are told ABCD is a trapezium. A trapezium is a quadrilateral whose opposite sides are parallel. So you can see that there is a pair of opposite sides here, which are parallel. So let's just put that into the figure. Always, given whatever information you have in geometry, you put it into the figure so you can see the information rather than the verbal information. See, this is the verbal information. When you put it like this, you can see what the information is. It's also given the diagonal BD is equal to AD.
Yeah.
I'm going to go to the participants, and I'm going to remove this person. Okay, the person has decided to be silent. I'll give the person a reprieve for the time being. So you've got this is equal to this also, BD equals AD. So I've got that into the picture there. And the question is DCB is 110. Angle DCB is 110, right? And angle CBD, CBD. So this angle here is 30. So these two, all these pieces of information are given. And the question is, what is the size of angle ADB? So there's a question mark here. It's ADB. So we need to get to that. All right. Now this is geometry. It's not a difficult problem. You go step by step, and what can we conclude? You've got two angles of this triangle. And you know that if you add the angles of a triangle, you're going to get 180 degrees. So these two together add to 140. So this would have been 40, right? Because 140 plus what gives you 180? It's 40. I'm here now. You got parallel lines. And this here, immediately you can get to alternate angles, because you can see you got your Z angle here. That is 40. So this is 40. So I'm here at this moment. But now you've got an isosceles triangle. These are equal. So you know that the angles opposite equal sides in an isosceles triangle are equal. So this is also 40. These are equal. Now you've got two angles of this triangle, which allows us to conclude that if you add them, you get 80, and this angle will have to be 100, because the sum of those three angles is 180 degrees. So that is how you do this problem. You'll notice that you have to do it step by step and use the information that is given to get to the answer. All right. Problem number 10. It says if 3 times the larger of two numbers is 4 times the smaller, and the difference between the two numbers is 8, what is the larger of the two numbers? Okay, there are a couple of ways of doing this thing. But let's try to understand what this question says. You got two numbers. We don't know what those two numbers are. So let's give names to them. Let X and Y be the numbers. And one of them is larger. So let's just say that X is greater than Y. Okay, 3 times the larger. That means 3 times X. That's the larger. Is 4 is, so it's equal to, that's your equation now, is 4 times the smaller. The smaller is Y. So there you have it. You have an equation. So you got 3X equals 4Y. But you're also given that the difference between the two numbers is 8. So you are given that X minus Y, that's the difference. The larger minus the smaller, that's equal to 8. Okay. And now you want to know what is the larger. So the question is, this is a question. Always keep your question in mind, because you are targeting towards that question. So we need to calculate X. We've got these two equations here. Okay. So let me eliminate Y from these two equations, because Y, I can make that the subject, and that's equal to X minus 8 if you bring Y to this side. So now Y can be replaced in the first equation. So the Y's go away. y is x minus 8. Now you have an equation which has only x's in it, so we can solve for this thing here. And I'm going to tell you that the answer is 32. You can try check it out at your own time. So the larger of the two numbers is 32. That's the answer to this question. Okay, there is another way of doing this thing. It's a more advanced way. So I can interpret this statement here, 3 times the larger equals 4 times the smaller. I can interpret that as a proportion statement. What do I mean by that? The larger, the ratio of the larger to the smaller is 4:3. That's what it says there. 3 times the larger is 4 times the smaller. So the larger is 4 parts and this is 3 parts. Right? Now, whenever you have a ratio, a proportion, it means that this x here, the first, is equal to something times the first here, and the same thing, the y will be equal to 3 times the same thing, k. It's a very, very important observation with ratios. When you got ratios, you can always say that the first one, you cannot conclude that x equals 4 and y equals 3. In a ratio, you cannot conclude that. But what you can conclude is that x and y are the multiples of the same number. So we're calling it k. So once you got that, then you can, then the difference between these two numbers, x minus y, you can see, it's 4k minus 3k, that is k, but it's given that k is equal to 8. The difference between these two numbers is 8, right? So what is the larger? The larger is x. K is equal to 8. So x is equal to 4 times 8, which is 32. Still get to the same answer in a different way using proportions. And these are important considerations when you are working with proportions. I'll repeat this. When you got two things in the same ratio, then you can say, you can have equations. You can say this equals, it's not equals to 4, it's equal to 4 times something, and y is equal to 3 times the same thing. And once you do that, then you got only one unknown, right? Rather than two unknowns, and you can solve. Okay. The next problem says all the consecutive numbers from 25 to 2008 inclusive, I write down the whole lot. Okay, well, I'm certainly not going to write down the whole lot, but we've got this written like this with a lot of dots in between. Okay. Now, how many digits have I written down in total? Now, what do you mean by a digit? If I write down a number like 25, this has got 2 digits. This is a digit, this is a digit, and there are 2 of them. 41987 has got 5 digits. And here now you want to know how many digits have you written down. Okay, now these numbers from 25 to 208, if you think about it, they are either 2-digit numbers or 3-digit numbers. From 25, you can go up to 25, 26, 27. And the 2-digit numbers finish at 99. And the 3-digit number starts here. And it goes up to 208. I'm separating the digits because I know I can count 2 at a time up to 99. And after that, I have to count 3 at a time if I'm writing down all the digits. So I need to know how many digits have I written here altogether. And how do you do that? Well, all these numbers have got 2 digits. So if you want to know how many digits you've written altogether, you have to see how many numbers are there first. And I told you earlier, these are consecutive numbers. So the number of numbers here is 99 minus 24. You remember I told you 99 minus 1 less than this. So the number of numbers in this is 99 minus 24. But the number of digits, that's the number of numbers. The number of digits will be 2 times that. That will be counting 2 here, 2 here, 2 here, and so on. And the same kind of a thing here. How many numbers have you got here? Here you got 208 minus 99. As I told you earlier on, if you go to one number just less than this. So there are 208 minus 99 numbers altogether. But how many digits? And each of these numbers has got 3 digits. So you have to multiply this number, the number of numbers, times 3 to get the total number of digits here. And this thing, it gives the total number of digits here. And altogether, you need to calculate how many digits you got altogether. And if you calculate this, I'm not really interested in calculating it, but just for the sake of completeness, I don't know. It's I think it's 847. You can check this thing out. But this is just an ordinary calculation here, which you can do. The important thing is, how do you count? You'll count how many numbers, 2-digit numbers there are, multiply that by 2. How many 3-digit numbers there are, multiply that by 3, and add the 2 numbers. So you see, in Olympiad problems, you have to figure out how to do it. That's called the strategy. You have to figure out the problem-solving strategy. So you think, understand the question and ask yourself, how do I go around answering the question? And then once you figure out the strategy, then you write down the equations. Okay, so the next question is, go to number 12. Tembi wants to arrange her collection of key rings in rows and columns so that each row is complete. Right? When she tries to arrange them in rows of 2, let's say 3, 4, or 5, there is always one left over. So what does this mean now? And she's got a number of rings. We don't know how many there are. But when she tries to put them in 2 in a row, at the end of that, she has 2 and she has 1 left over. Now, when she does it with 3s, you get the same story. When she puts it in 3s, and so on, you come to the last one, she has 1 ring left over. The same thing with 4s. And 5s. Okay. Now, if Tembi has got more than 1 key ring, the question is, what is the least number of key rings that she can have? So you will see here, when you draw this picture here, you see, if I say we don't know what the least number is. So let n, we'll put a capital N here, be the answer to the question. So what does that mean? N is the number of key rings she has, and it's the smallest number of key rings she can possibly have to get this situation. Okay. Now, so this entire number of dots here is n. And here too, the total number of dots is n. Here to the total number of dots is n, total number of dots is n. That's including this last dot here at the end. Now, if you look at this picture nicely, you will see, so what's happening here is that the total number of dots is n. Let me remove the last dot. I'll remove one of these key rings. Then I've got, it all fits in exactly. Now this thing here, how many key rings do you have here? This thing here is 2 plus 2 plus 2 plus 2 several times. So n minus 1 is a multiple of 2 because it is 2 added to itself several times. So if I remove the 1 here, again, if I remove the 1 from the same number, this time I have that it now becomes, and it's also a multiple of 3. It's a multiple of 3 also, because now this is 3 plus 3 plus 3 several times. And in this case here, it's also a multiple of 4. And likewise, it's a multiple of 5. Okay. So I hope you understand. I'm drawing a picture here and I'm saying there's always one left over. So if I take that one away from this, from the number of key rings she's got, you will see that that new number is a multiple of 2 and a multiple of 3 and a multiple of 4 and a multiple of 5. So what do you have? You see, in short, you have that I said let n be the number of key rings which she has got. And we have just concluded that n minus 1 is a multiple of 2, 3, 4, and 5. Now, in other words, it's a common multiple. Right? One number is a multiple of the whole lot. So n minus 1 is a common multiple. But they're asking you for the smallest value of n. The least n. Means you're looking for the least common multiple. And there you have it, LCM. That's what you mean by LCM. The least common multiple of 2, 3, 4, and 5. You're looking for a multiple which is the smallest. And when you make the calculations for that, right? I'm not going to do that. You know how to do it. And if you don't, go back to your grade 3 or grade 4 or grade 5, whatever it is, and see how you find the LCM of a collection of numbers. So the least value for n is, or the least value of n minus 1. So this is equal to n minus 1. N minus 1 is the least common multiple. So therefore n must be 61. N minus 1 is 60. So the answer to this question is 61. Although the problem looks very difficult, it is making you understand what do you mean by common multiples and what do you mean by the least common multiple. Normally you would just do it in school, you're just given the numbers and you mechanically calculate the LCM without understanding what it means. So it's a common multiple, which is the smallest common multiple. That is what it means. So this tells you the meaning of LCM. At the same time, we can solve our problem. So this is the smallest one. The other way of doing this is we could have done it like this by saying that the number that you're looking for, it's been too long over this, it's going to be, it could be 3, because when you break it up into 2s, you get one remainder. So it's the odd numbers. So your number of rings is going to be an odd number. So it's in that set. And likewise, because 1 is left over when you take groups of 3, then it could be 4 because 1 is left over. Or it could be 7 because 1 is left over when you take groups of 3. And what happens here is that you just keep adding 3. So your number is here and it's also here. And likewise, your number is, when you're taking in groups of 5, there is one left over, or 4. So it's 5. It could be 5 because when you take groups of 4, you're going to get 1 left over. But this time you're adding 4. All these numbers, when you divide by 4, the remainder is 1. That's another way of looking at it. And likewise, so you're looking for the smallest number, which is in all these 3. You can write the whole thing down, but it'll take you a long time before you come to 61. You will see the 61 is in all 3, but you wouldn't see any number smaller than that occurring. You could have done it like that, but it takes a lot of time. But if you use logic, you'll see how quickly we can get to the answer. Can we now go on to problem 13? The lengths of 2 sides of a triangle are 200 and 150 centimeters. Okay, so let's just draw this triangle. One side is 200 and another is 150. The length of the third side is also an integer. Right? So the question is now, what is the minimum perimeter of this triangle? This looks like a very hard question. But what is the perimeter? The perimeter, as we saw earlier on, is the length of the boundary. So we've got 2 sides in the boundary, so we don't know the third one, so we need to calculate. We don't know the third one. Give it the name x. We didn't need to calculate x, so let me just, I won't put a question mark here because this is not what we're trying to calculate. We calculate the minimum perimeter. Okay, so what is the perimeter? If I call this third side x, the perimeter is the sum of these 3 numbers, which is x plus 150 plus 200. And 200 plus 150 is 350. So we want to calculate this. Now, why is this problem strange? The thing about this is that I suggest to you that it's impossible that x is equal to 1, for example. Okay, maybe I don't have time to go into the details of that, but there is an important fact. Let me just write down that fact rather than explain why it is true, because that will take time. Important fact. The sum of 2 sides of a triangle is always greater than the third side. Right. This fact is called the triangle inequality. It's got a name, triangle. So whenever you see the word triangle inequality, you must know it is the statement that the sum of 2 sides of a triangle is greater than the third side. So if you look at x now, x can't be 1 because 150 plus 1 is not bigger than that. So if you look now, you want to get the minimum perimeter, right? So you're looking for, this is the perimeter. So you're looking for the minimum x, the smallest value, possible value you have of x. Because to get the smallest value of x plus 350, you need the smallest value of x. So let's go through those numbers from 1, 2, 3, 4 and see which is the first one which makes that true. And I wouldn't do the whole lot, but I'll notice that when I come to 50, I get them to be equal. 150 plus 50 is 200. But that can't work because it must be greater. It's not allowed to be equal. So 50 is not allowed because the sum of these two equals 250. So the smallest one will be 51. That's the next one. If you take any number smaller than 50, you will get this plus this is less than 200. That doesn't work. And when you come up to 50, it's equal. That's not allowed. And then the very first one after that is 51. So that is the smallest number for, no, the answer is not 51. The answer for x, the x value is 51. But your problem was to find x plus 350. So your real answer is x is 51. So your answer is 51 plus 350. Because you always answer the question, be careful. You can get trapped. A lot of people know how to do it. They don't read the question and they write down a wrong answer. Okay, so always make sure you know what the question is. The question is, what is the minimum perimeter? So you first work out what the perimeter is, and then you want to work out the minimum value of that. And then you argue the smallest value will be obtained when you get the smallest value for x. And the smallest value for x in this problem is 51. And then you can substitute that, and that will give you the minimum perimeter. The answer is 401. So I actually had some space here, which I didn't use. Okay, we are on to problem 14. We just passed the halfway mark and we almost at 5 o'clock. So you can imagine we are doing more difficult problems. It's going to take a longer time. Okay. Problem 14 says the number 49 is special because it is possible to add the product and the sum of the digits to get 49 again. What is the meaning of that? So if you add the product of the digits, these are the digits, the product of the digits, and if you add, there's your add here, if you add the product and the sum of the digits, the sum of these two is 4 plus 9. This is the sum. So the product plus the sum is 36 plus 13, and you get 49. You come back to the original number. And the question is, how many such two-digit positive integers are there altogether? 49 is a two-digit number which has this property. You want to know how many such numbers are there. All right, now we start getting into the mathematics. Now, a two-digit number can always be written like this. It's an important fact. Let me just explain what this means. If you had, for instance, 29, right? 29 is really, this is the 10th unit, this is units. So 29 is 2 10s plus 1 9. Okay. 73 is 7 10s plus 1 3. Any two-digit number is, the tens unit is 6 tens plus 1 5. So we want to work out this two-digit number, but we're going to call it AB. I want to find out all the two-digit numbers. So let me give two symbols to them, because those have become the unknowns. These are digits. In other words, they are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But A can't be 0 because it's a two-digit number. So just bear in mind, it's a two-digit number, so A can't be 0, right? And if this is your number, this is my two-digit number, and its actual value is 10A plus B. Right, so what is the property? We saw that the question is, you multiply, somebody has got their mic on and they're making a noise. Can you please take your mic off? We said that if you multiply these two numbers, that means A times B, and you add it to the sum of the numbers, that's the sum, A plus B, you're going to come back to the original number. Remember, you had 4 times 9, 36, plus 4 plus 9, 13, and you come back to 49. So you come back to the original number. Now the original number is not AB. The original number is 10A plus B. The value of that number is 10 times this first digit plus this. So this thing here is not the same as that. This is the product. So I think maybe we should do it like this, to say this is the tens unit and this is the units, right? So if your A is your tens digit and B is the units digit, then the value of this number is 10A plus B. So there it is, you got your equation, right? And if you work out this equation, the B's cancel. You have AB is equal to, or let's put it this way, AB minus 9, I'd rather do it like this, 9A, 10A minus A minus AB equals 0. It doesn't matter which way you do it. This is 9A. The B is cancelled. If you bring the A to the other side, you get 10A minus A, that's your 9A. You bring your AB to the other side, you get minus AB, and that's equal to 0. A is a common factor here. And now that equation that you have, you land up at this place. The question is, now how do you proceed from this? This is 9 minus B, sorry. Okay, A into 9 minus B. Now watch. It's a very important fact I'm going to say. Just listen. Yeah, you got a product of two numbers, and the answer is 0. When you multiply two numbers and the answer is 0, one of them must be 0. A equals 0. Either that is 0, or the other one is 0. When you multiply two numbers and the answer is 0, one of them has to be 0. That means that either A is equal to 0 or B equals 9. But we said that A is not equal to 0 because it's a two-digit number. And this A equals 0 is not allowed. So we are saying that B equals 9. So it is said that B is equal to 9. So in other words, the units digit is 9. This calculation tells us that the units digit is 9. It doesn't say what the tens digit is. Since it doesn't say what the tens digit is, it suggests that anything can go for the tens digit. So the units digit is 9. So it's a two-digit number. So 19 29, 39, 49, 59, 69, 79, 89, 99. But nothing is said about A, you see. All we know is that the B value is 9. Nothing is said about this. So it suggests that anything goes. You'll notice that 49 is one of them. See? So this was the number that was given as an example. But our calculation says that 89 is also an example. Let's try 89. What is 18? If you multiply 8 and 9, you get 72. 8 times 9. Plus, what is 8 plus 9? That's 17. And 72 plus 17 is 89. So you come back to your original number. So this is allowed. Okay? So like that, all these are allowed. And the question, let's go back to the question. Always answer the question. The question is, how many such numbers are there? And the answer is, you just have to count how many there are here. I think there are 9 of them. Nine such numbers. They're all 2-digit numbers. And they all have this property. So you can see here, I'm using mathematics here to solve this problem, right? You probably will do it by trial and error, and it'll take you a long time to get to that. But if you use mathematics, mathematics is very powerful, because then you can get an equation and you can solve. So to get the equation, you have to interpret what is given. It says that the product of the digits, that's your product, plus the sum of the digits, that's your sum, equals the original number. And the original number is that. Now you have an equation, and you try to solve this equation, right? The b's cancel, and you bring all the a's to one side, and eventually you get an equation like this: a into 9 minus b equals 0. And then you argue it out, and you say that one of them is 0, and go on to solve the problem. Okay, so now we get on to the even more difficult problems. But in each case, there's thought involved, and you have to think about what is going on and try to solve the problem. Now, in this case here, there's an ant which lives on the surface of a cube, right, that has X, Y, and Z on the 3 faces. So the ant, it lives on this thing here. Now the ant travels between X, Y, and Z along the shortest paths between each pair of points. So it comes to, when it's X now, it wants to get to Y, right? And to get to Y, it takes the shortest possible path. So you can see this kind of looks like short. It obviously wouldn't go there and come down here. It wouldn't go there and come down here. Somehow it'll take the shortest path. We'll have to analyze that just now. And the same thing, when it travels from Y to Z, again, it takes the shortest possible path here and here too. So in each case, as it goes around, traverses from X to Y to Z and back to X, right? It takes the shortest possible path. Now, it's given that this angle here is small x, this angle is y, this angle is z. And the question is, what is the sum of the 3 indicated angles x, y, and z? All right, I'm going to just transfer all this information into another page. And I'm going to analyze what we are doing here. So this is the same picture, but it's a smaller version. It is given that the ant travels from X to Y, from Y to Z, and Z to X. In each case, it takes the shortest possible path. Now, what do you mean by the shortest possible path? The way to decide what the shortest path is now listen very carefully. I'm going to take the top lid of this box where X is, and this lid here, and I'm going to flatten it out. I take this, lift it up, like what I'm doing here. And now I've got X is on the top lid and Y is in the bottom lid. And now when you see how to get from X to Y, it means I'm taking the straight line from X to Y when you spread it out like this. You see here, it doesn't look like a straight line here because you got, this is flat and that is vertical. But when you lift this thing up, it will have to be a straight line because that's the shortest possible path, right? So what I'm doing here is I'm just looking at this part here, X, A, Y, X, A, Y. A is where it intersects here. But since this is a straight line, this angle here, 1, and that angle there, they both add up to 180 degrees. That and that, because this is a straight line. So what we have here is A1. I'm going to call this top angle A1 plus A2 is 180 degrees. And for the same reason, you're taking the shortest possible path from Y to Z, you will have that B1 plus B2 is also 180. They also belong, these two angles are part of a straight line. And the same thing with C. I'm calling this angle here A1. This angle, I'm calling it A subscript 2. Okay. So you got all these equations. And now you need to find out what is X plus Y plus Z. X is an angle there, Y is here, Z here. But you'll notice that X is an angle in a quadrilateral. So X is one of the angles in a quadrilateral. And here, this quadrilateral, the top quadrilateral got an angle. This is 90 degrees there because you're working in a cube. And so this corner angle is 90. So if you look at this quadrilateral here, the top quadrilateral, right? You got 4 angles, X, 90 degrees, A1, and C2. Now here in this quadrilateral, again, you got 4 angles. You got that, A2, Y, B1, and 90 degrees. And in this quadrilateral also, you got the same story. So I need to work out X plus Y plus Z. So let's just see X is part of an equation because it's one of the angles of a quadrilateral. So let's put that equation down. X plus A1 plus C2 plus 90 equals 360 degrees. I'm looking at this quadrilateral here, right? Those 4 angles I can see, and the sum of those 4 angles is 360. In any quadrilateral, the sum of the angles of a quadrilateral is always 360. So if you write that equation down, you're going to get this. Likewise, in this quadrilateral where Y is, you've got Y plus A2, that one, plus 90. This one here, that's 90, plus B1. Is also equal to 360 degrees. And you got one more quadrilateral to go through, and that is Z plus C1 plus 90. This angle here is 90. And this angle is B2. That's also 360. We want X plus Y plus Z. So the way to get X plus Y plus Z is to add everything here. So when I add X plus Y plus Z, I'm adding these 3 equations. Right? Okay, let's add them. I got 3 90s. And I've got those, I've got it there. 3 90s will give you 270. Right? And you've got 6 other angles. You got A1, C2, A2, B1, C1, B2, but A1 plus A2 is 180. These together give you 180. B1 plus B2, those two give you 180. And likewise, what's left over, that's also 180. So when you add the left-hand side, you're getting that number, and here you got 3 times 360. And now you can calculate x plus y plus z by taking all these angles across, and you can do it. I'm not going to do it. The answer is 270 degrees. So it's a very nice problem. Very little information is given, but you can ask a question and get the answer. But to do that, you have to interpret, what do you mean by the shortest possible path from x to y? And to do that, you have to lift this path, that box lid up like that and merge them. And then you can see what the shortest path is. Let it be the straight line. And then the observation from that is that these angles here, these two actually add up to 180 degrees. And once you observe that, then the rest of it falls into place. So as I said earlier, I'm doing all the talking. And the reason for that is we've got a very large class, 247 participants here, and it's impossible to attend to the queries of all of them. And it can be quite a jungle out here. Right? Even now, there are still people who have got their mics open. I can hear noises every now and then. But we are now on problem number 17. And you can see none of these problems are problems which you see at school. But they are problems. You have to figure out what's given, read the problem, understand what the question says. You might have to draw diagrams. And then the most important thing is you have to understand exactly what the question is saying. And then you find a method of finding the solution. And invariably, you need to get to an equation. And the information that is given often gives you the equations. They are given verbally, but they lead to equations, mathematical equations. Now, the next problem involves a function of x, f of x. And this is the rule, right? It's ax to the power of 7. It's something that we have never seen, because 7th degree polynomial. Usually you have quadratics or cubics. And a, b, and c are constants. You are told that f of negative 7 is minus 29, and you're asked to calculate f of plus 7. Right? What do you mean by this? It means that if I substitute for x, if I substitute negative 7 into this formula, the answer that you will get is negative 29. And the question they ask is, what happens when you substitute plus 7 into this? You might be tempted to say that the answer is plus 29. I'm sure many people will do that, but let's see whether that will be the correct answer. Okay, I'm going to get onto a new page because we need some space. So let's take the first information. There's an f of negative 7. Okay, let's substitute negative 7. What do you get? X is negative 7. I'm going to put that in brackets because that's raised to the power of 7. And there's a minus sign. So we need to put that in brackets. B, negative 7 cubed. I'm replacing x by -7. Replacing x by -7. There's no x to replace here. So let's simplify this. You got -7 multiplied by itself 7 times. So the answer will be negative. It will be minus a. I'm not going to calculate what that is. I just want to put the correct sign in front. -7 cubed, you could still got a minus. Minus b times 7 cubed. The -7 all cubed is minus 7 cubed. And the same thing here, you got minus 7 minus c times minus 7c. And plus 5. That is what f of minus 7 is. So, but we know that this is equal to -29. It's given that when you substitute -7, you're going to get -29. Now that allows you to calculate just this part here. Okay, because I've got an equation here now. I've got an equation. So let's bring all the unknowns to this side. I'm going to get a times 7 to the power of 7 plus b times 7 cubed plus c times 7. These, I'm taking it to the other side. That is equal to 5. And I'm bringing the 29 to this side. I know many of you will leave this here and take that to the other side, but I don't like negatives, right? So I'm instead of changing the sign later, I take this thing and put it this side straight away, so I get positives. So I've got an equation. Now the question is to calculate f of 7. So let's put 7 into this equation. What do you have? You got a times 7 to the power of 7. I'm putting 7 here, x equals 7, into the formula for f of x. You got b, you put a 7 here, you got 7 cubed, plus 7 here, plus c times 7, plus 5. So there is f of 7. But we've just calculated this part here, you see? Oh, there's a b here. We just calculate this part here. We saw it was 34. This part here. I don't need to know what A, B, and C are, but I know that this quantity here is 34. I'm sorry, 34 plus 5. So the answer is 39. So your guess that it's plus 29 wouldn't work. The answer is 39. So that's how you do that. This is a test on understanding what functions are. And again, you know, you have to take the given information and try to simplify it so that you get some nice equation and then proceed. And this is what I did. Now I just took out all the negative signs and so on and I made it neat. And I saw that straight away, the moment I do that, things just open themselves out. Okay, so the next question is points A and B with respective coordinates. Now they give you the coordinates of A and B. They lie on the line having equation. This, what is the distance between A and B? I'm going to go to a new page and just transfer all this information to the new page. Right? The writing is small here, but I'm going to put all these now in a coordinate frame. Points A and B right? So it's a pair of numbers. So I'm going to put my x-axis and y-axis. X-axis and y-axis. And you see, if you locate the point AB, 3A at least, so the x value is 3, the y value is A. So I'm putting that down in this picture here. 3A. Right? It's very important to know what do you mean by the coordinates, right? If the coordinates are 3 and A, that means the first coordinate is 3. That distance there is 3. If you come down perpendicular, that's 3. And that way, this distance here is A. Okay, can you please, I don't know who that was, can you please put your mic off? Was that Ronald?
Nu räcker dagen nu då. Welkom.
Now, somebody disturbed me and I had to wait for that person to go away. Unfortunately, I'm not being able to remove him because he didn't follow instructions, but I will find out sooner or later how to do it. The next one is, the second point is 11, the x coordinate is 11. The y coordinate is B, so that is B, I've made that a little bit larger. So that is B now. Okay. And the question is, what is the distance between A and B? So you got 2 points here, and you want to calculate that distance, right? And you can complete a right angle triangle like this, and this distance can be calculated. Okay, so your distance between A and B is AB. From Pythagoras, when you complete the right angle triangle, you're going to get the square, this becomes the hypotenuse. That's what I need to calculate. It's equal to this length. Well, that is going to be, from here to here is 11. So from here to here it's 3. So that length will be 11 minus 3. You're going to square it because we're applying Pythagoras. This squared plus that squared. And that squared is this whole length, which is B, minus this piece, all squared. So this piece here is B minus A. And so you have 11 minus 3 is 8. 8 squared is 64 plus B minus A all squared. Now the question is now, how do you find B minus A? There is an information that was given which you haven't used yet. So we need to work out this thing here. It is given that these 2 points lie on this line. Now, when you say that this point lies on that line, it means that when you substitute 3 for x, you're going to get A for y, right? And that's the equation of a line. That is what you mean by the equation. When you substitute the x and the y, it satisfies the equation. So when y is b, x is 3, or when x is 3. So you get 3 times square root of 35. That is x times plus k. And this point also lies on the same line. And this time, I'm sorry, this is A. when the x coordinate is, when x is a, x is 3, y is a. Now likewise, you've got b here is equal to 11 times square root of 35 plus k. We need to calculate b minus a, so let's just do that. B minus a, you have to subtract these two equations. And the k's cancel, so you'll have 11 root 35 minus 3 root 35. That will be 8 root 35. B minus a, you just simply subtract b minus a, 11 minus 3 is 8 root 35, k minus k is 0. But we need to calculate b minus a all squared. So that will be 64 times 35. Calculator is not allowed, so we'll just leave it like that. Maybe we can simplify it. Okay, so that is b minus a all square. I can put this back inside here and I get 64 plus, this is 64 times 35. Now you see, the beauty of mathematics comes in now. I'm not going to calculate this. I'm not going to add this. I'm not going to work out the square root of this in that way. What I see here is I see I've got 64 here and I got 64 here. I can take 64 out as a common factor, right? 64, it goes into this one time plus, and 64 goes into this 35 times. So you have that this is 64 times 36. 1 plus 35 is 36. And that's AB squared, and straight away you can see what the square root of that is. You need to calculate AB because it's the square root of 64 times the square root of 36, and the answer is 48. So although this problem looks very difficult, if you draw a diagram, as I've done, calculate the distance, you need to calculate the distance. There you have to think a little bit. If you have done analytical geometry, which people do in grade 11 or grade 12, then you'll just use some formula, but I didn't use any formula. I just do, or to calculate this distance, all I do is complete a right angle triangle here. And I can calculate this because I know this length here is the same as that length, opposite sides of a rectangle, and I know that this length here is the same as that length, and that is b minus a. So I've got Pythagoras, use Pythagoras, and then you suddenly see that this is your unknown, and you use the extra piece of information to calculate that quantity, and miraculously you get to your answer. It's a very nice problem. Problem number 18. It says, I have a 3-digit number, ABA. Now, this is a 3-digit number. Right? So this is not the product, with A and B different. The 3-digit number is not divisible by 4, and the sum of the 3 digits is 15. How many different 3-digit numbers are there? Now, again, this looks very complicated, but I'm going to break that into small pieces, and for that, I'm going to get to my other page here. I've repeated the question here. So I've got a 3-digit number. Let's just put them in hundreds and units. And if I separate these, so this is A is here, it's a hundreds unit, and this is B, and this is A. That's the number that I've got. Right. A and B are different. So the actual value of this, which I'm not actually going to calculate, but the actual value of this number is 100A, A hundreds, 10 B's, and the units. So the actual value of this is 101A plus 10B. But I'm not going to worry too much about that. The 3-digit number is not divisible by 4, and the sum of the 3 digits is 15. Now that is very useful. So I've got A, B, A. When I add them, I get 2A plus B is 15. Now remember, these are digits. A is not equal to 0 because A is a 3-digit number. So the first digit is not 0. We might have to use that. And then we know that 2A plus B is 15. Okay. Now here you have to think a little bit. Now watch carefully, because when you have digits or whole numbers or integers, we are working with such objects here. The A and B are not fractions or real numbers, any real number. They are whole numbers. So when you got an equation like this where these things are whole numbers, you can say that this is a multiple of 2 because A is a whole number. So this is an even number. See? Because it's a whole number. So you got an even number added to B to give you 15. And the only way that is possible is that if B is an odd number. So B will have to be an odd number. So what are the possibilities? You've got the middle number is odd. So the middle number can be 1. But if the middle number is 1, then the A's are the same number on both sides. So that becomes your 3-digit number because they all add up to 15. Now the middle number can't be 2. You can try B equals 2. But if you put B equals 2, then you have 15 minus 2, which is 13. And 2A cannot be 13, right? And as I said, the reason for that is this middle number can't be even. It can't be 2. It has to be 3, 5, 7, or 9. It has to be something like that. Those are the possibilities for the middle number. They all add up to 15. So these two add up to 12. These two add up to 10. These two add up to 8. And these two add up to 6. Right? We're adding up to, they all add up to 15. So you have to take away the middle number and you'll see what the sum is going to be. Right, so these are your possibilities. So we've used the fact that the sum of the 3 digits is 15. But they give you, they tell you that A and B are different. So this thing here must be eliminated because here the A and B are the same, right? So that must be eliminated. That is not a possibility. But it also says that this number is not divisible by 4. So here we are testing the divisibility by 4 rule. How do you know when a number is divisible by 4? And I'm sure all of you know this by now. A number is a multiple of 4, provided the last 2 digits is a multiple of 4. Must be like 28 or 40 or 48. And the last 2 digits must be a multiple of 4. Now this thing here you can see is a multiple of 4, the 36. And it says that this is not a multiple of 4. So that must be eliminated. But all these others, none of these have that property. The last 2 digits is not a multiple of 4. The question is, how many such 3 digits number are there? There are only 3 answers. The answer is 3. That's the question. How many such 3-digit numbers are there? So you can see in this question here, it's just simple common sense logic, right? Use a given information to get a 3-digit number. Add them, you get an equation. And then don't look at this and say, well, I can't solve this equation. You must ask yourself, these are whole numbers now. So they're not any number, they're integers. They are positive integers, 0, 1, 2, up to 9. So you try to see what are the possibilities here. And you will see that these are the only possibilities. The middle number B will have to be an odd number. And then once you got that B, you can substitute it here and you can get A. See, each time you got a value for B, you substitute here. That's how I got all these. And then you use the extra information to eliminate these two, and therefore you can count it. So it's common sense leading to, let's go to problem number 19. Problem 19 says, for each positive integer k, let sk denote the increasing arithmetic sequence of integers whose first term is 1 and whose common difference is k. Let me go to my bigger page. Right, for each positive integer k, let sk be the increasing sequence of integers whose first term is 1. Okay, let's read that as it stands. The first term is 1. So it's a sequence. So you're going to separate this by commas now. It's a sequence. The common difference is k. So it means that I'm adding k to get to the next term. And I'm adding k to that. So it becomes 1 plus 2k. I'm adding k to this. So each time you keep adding k because it's a common difference. So this is your sequence. And this sequence, they give it a name, they call it SK. So you can have different numbers for k and you'll get different sequences. Like they give an example. For example, S3, if I put k equal to 3, then I'm adding 3 all the time and you get 1, 4, 7, 10. So k, in this case here, k equals 3, because sk is, you got 3 is your k, and that will be the sequence. Now the question is, how many values of k does the sequence, I should say, does the sequence contain the term 2019? Now, let's just understand this. We don't know what k is, right? So we're not going to put any value for k here. We need to work out how many such k. So we need to solve for k. But we know that the sequence here contains this number. Now watch. The terms of the sequence can be written as 1 plus an integer, 1, 2, 3. Let's call that integer n, where n equals 1, 2, 3, and so on. So the terms of the sequence are this, and we want one of the terms somewhere here to have 2019 in it. Right? For how many values of k does the sequence, I should have said the sequence. So one of these is 2019, but the terms look like this, 1 plus an integer times k. So you want this thing here to be 2019. Right? So what does this mean now? Remember, n is a counting number. It's 1, 2, 3, 4. N equals 1 or 2 or 3 or 4. Right? And k is also a positive integer. K is also positive integer, 1, 2, 3, 4. So if you make this your subject, you got nk is equal to 2018. What does this mean? It means that when you multiply these two numbers, you're getting 2018. So what are the possibilities? All right. 2000. So in other words, n and k are factors of 2018. (2018) is 2 times 1009. Now, this question was evidently set into 2018, as you can see. We are doing 2018. And in that year, people should have known, Olympiad should have known what the factorization of their year is. Like you guys should know what the factorization of 2022 is, and that is 2 times 1011, and that is 2 times 3 times 337. And this is a prime number. Let me tell you that this is a prime number. So the prime factorization of 2022, useful to know because you might have to use it, is that. And in that year, they would have known that 1009 is a prime number. So now so the question is now, the K that you're looking for is going to be a factor. N times K is 2018. So what are the possible values for K? K can be 1, right? And of course, then N will have to be 2018 in that case. K could be 2. In that case, it's 2 times 1009. But after this now, the only other one is a prime number, you see. So K could be 1009, in which case K is equal to 2. I'm sorry, N is equal to 2. Or K can be the whole thing. In which case K is equal to 1. Right? So there are 4 values for, I'm sorry, N is equal to 1. N times K is 2018. This is your dominant thing. The product of N and K is 2018. And that gives you only 4 possible values for K because you got factorization, you see. So you have to ask yourself, what are the factors of 2018? There are only 4 factors, and these are the 4 factors. Okay. So there are only 4 values for K, and the answer is let's just check these things out. If K equals 1, remember K is the common difference. Then you will have K equals 1, you're adding 1. And surely 2019 will certainly be there. Okay. Then the next one for K is K equals 2. So you're adding 2 now. 1, 3, 5, 7, so on. And certainly you're going to hit 2019 here because that's an odd number. These are all the odd numbers. So like that, you can easily check that these 4 sequences contain 2019. And that was the question. See? So to just quickly go back on this, you write down your sequence, interpret your question and say one of these terms is 2019, and that gives you an equation. And then from there, you use your common sense and logic to decide how you're going to calculate this K here, bearing in mind that it's a positive integer, right? So therefore, you don't have many solutions, and that is how you do that. Okay. So to get on to the next problem, problem number 20. For how many real numbers A does the quadratic equation this have only integer roots for x? Now, you've got a quadratic equation. This is right up your street now, because in school, you learn a lot about quadratic equations. Now, it has only integer roots. What do you mean by a root? It means that when I substitute that number for x, you're going to get 0. They are the solutions to this equation. But A is not given. The question is, how many A's are there in this problem, which will make this equation have integer roots? Okay, now that is a non-routine problem. It's a kind of problem that one can ask in grade 12, the final exam. It will be a high-level problem solving. But I'm sure I'll show you how to do this thing, and it's, when you think about it, maybe it's even more than metric, but let's have a look. Let's analyze this problem. this quadratic equation has got two roots. Let's give names to them. Let m and n be the roots. What does this mean? If these are the roots, which quadratic equation has got these roots? That's very easy. This is the quadratic equation whose roots are m and n. But they tell you that this is the quadratic equation, so these two must be the same. This quadratic equation has got roots m and n. I'm calling the roots m and n. They are integers. They say integer roots. The whole numbers. And this must be the same as that. And when you expand this, you're going to get x squared minus m plus n. Group the x's together, plus mn equal to x squared plus ax plus 6a. And these two are exactly the same quadratic, which means that this coefficient here the coefficient of x here is negative m plus n. It must be equal to this coefficient because it's the same quadratic function. Now here the constant term here is mn, and here the constant term is 6a. Okay, so you got these two equations like this, and you want to see, you're going to solve for them. You got two equations, but you got three unknowns. Right? The best thing to do is to eliminate the a, because we know m and n are integers. Right? So how do I eliminate the a's? To eliminate the a's, I have to multiply this by 6 and subtract. Maybe I can multiply by negative 6. Negative 6. This first equation, I multiply this by negative 6 on both sides, I get this. Why do I do that? Because I want to get rid of the a's. Now I'm going to add them. Mn plus 6m plus 6n, that's equal to 0. So how are we going to solve for m and n now? So we've got an equation involving the two roots. We've got one equation involving the two roots. I remember they are integers. The way to do this is actually, let's have a look at these two terms. You'll have m is a common factor, the m into n plus 6 plus 6n equals 0. If I can factorize this left-hand side, then I would get somewhere, because we saw earlier on to when you factorize in amongst integers, when you factorize, you can talk about factors. But at the moment now, I can't factorize unless I put an n plus 6 here. So what I'm going to do is I'm going to add, this is the tricky part. I got m into n plus 6 plus 6. But what I'm going to do is I'm going to put 6 into n plus 6. I'm going to force an n plus 6 here. Equals 0. But what happened here? I've actually I've got the original, but I've just added 36 to it. I've added 6 times 6 on both sides. And when you add 6 on both 36 on both sides, you get this, and now this is factorized. And we need to actually calculate how many A's there are. And to do that now, we've got the product of two numbers is 36. That will help us a great deal. But you must remember these are integers. So you'll have that the pair m plus 6, comma n plus 6. There are lots of possibilities for that. It can be 136 or -1 minus 36. They're integers, you see. So you can have -1 times minus 36. And like that, you can go on. I'm not going to do it because we don't have sufficient time. So that will give you the pair m plus 6 and n plus 6. But I want to know what is A? The A is here. The A is actually equal to, or maybe we should do calculate negative A. Negative A is equal to m plus n. And that is the same as this quantity plus this quantity. Those quantities we know, it's m plus 6 plus n plus 6 minus 12. Because m plus n, I'm balancing the equation out. Why do I do this? Because when I do this, these I can calculate. So for example, one of them is this is m plus 6, n plus 6. When you add these two, I get 37. You subtract 12 and you get 25. So negative A, one of the answers is 25. So therefore, one of the answers for A is minus 25. Now you got a lot of things here. So you have to go through you need not go through the whole lot. All you have to do is to say, how many such pairs have you got? Because each one will give you a value of A. Each pair, and I can see that there are 9 such pairs, but I think we might have to eliminate one, I'm not sure. But it seems to me that there are 9 such pairs. So therefore, you just have to look at how many pairs do you have, and that will give you, each pair will give you a value of A, right? But we don't know whether the A's are repeated or whatever. It seems to me that if they're all different, they're all the A's. How do you get the A's? You add these two. Remember, A is minus A is m plus 1. So I have to add these two and subtract 12 from that to get m plus n. So that is what I did. I add these two, 37, subtract 12 to get 25, but that is negative A. Let's just check this. If A is negative 25, you get x squared minus 25x minus 150 equals 0. Now, when you try to solve this, I can see very quickly that you get, this is x minus 30 into x plus 5. Right? When you factorize this, you can factorize it, and you see the values for x are 30 and negative 5. See? And these are integers. So Negative 25 will give you integer solutions. But like that, there are 9, I think. You have to try it out. There are 9 values for A. Because the number of values for A is the same as the number of pairs of solutions, number of pairs of numbers, which when multiplied gives you 36, right? And you can write down all those pairs, and you can do it. I'm not going to do it because we don't have time. And you will see there are 9 such pairs. Okay, so that's problem number. Okay, it is now 6 o'clock, and we've still got 5 more problems because we've done 20 problems. I'm not going to be coming back to these problems because I want to go on to 2019 for next week, 2020 the following week, and 2021. But what I'm going to do now is I'm just going to pause here. By the way, I should have given you another house rule, and that is in the chat column. People write down all kinds of things in the chat column, which is actually abusing the chat column. I need to get to the chat column to find out what are the legitimate questions. The only reason I should have told you in the beginning, and please do this in future, in the chat column, if you've got any questions, you put it in there. Don't write down things which have got nothing to do with this class, right? There are lots of people who put all kinds of things, trying to crack jokes and so on and so forth. This class is not meant for that. So use the chat column with discrimination and put down questions there. So at the moment now, what I'm going to do is I'm just going to entertain questions. And after that, those who remain behind, I will do the remaining 5 questions. It might take me a little bit of time, but I don't want to hold the rest of you up. If you want to go, you can, or you can ask me the questions now, or I can go on to do the 25 questions. Let's just get some urgent questions going. All right, I'm going to unmute you so that one person at a time can ask these questions. Okay, let's go to the major. Can't seem to. Okay, does anybody have a question? Let me unmute you first. Anybody? Is it Matsi? Matsi, do you have a question?
When is the next lesson?
The next lesson is next week, Thursday at the same time. What's the next question? Okay, Ntabisi, what's your question?
Professor, I would like you to help me with
Ntabisi, I can't hear you.
with how you ended up with the next.
I'm sorry, there's a problem with your sound system, Ntabisi, so I can't hear you. All right, I have to go to the next person. Ayavu, what's your question?
Sir, when can we find the recordings?
The recordings, I will send the recordings to you. Oh, just hold on. Okay, the recordings will be posted on Google Classroom. Okay, and you can get it from there. Okay, Sen.
Thank you, sir.
Okay, Luyanda, what's your question?
Yeah, I was asking like question 20, I didn't understand, sir.
Which question is that?
Question 20.
Question 20, yeah? All right. Luyanda, if you
Yeah.
can just stay back towards the end, we will address that question. Question 20, I'll make a record of that. Uwila,
Okay. Sir.
I was going to ask for the same person, for the same question, question 20.
question 20, all right. So both of you, if you stay till the end, I will finish the 5 problems and I'll come back to question 20. Okay. So please mute yourselves now. I don't think there are any other questions. Those are the only ones with the raise. Are there any other people who want to raise their hands?
I didn't understand question 16.
Question 10.
16.
Okay. So I will do 16 and 20. Any other question?
So with regards to the past papers, how are we supposed to answer the questions?
I'm sorry, I didn't get that.
So with regards to the past papers, how are we supposed to answer the questions?
I think you have to write down the answer. I'm not sure whether they give you multiple choice.
Yes, there's no multiple choice.
Yeah, so they'll just give you have to work it out and write down the answer. All
Okay,
right.
thank you.
You don't have to show working. You just have to write down the answer.
Okay.
Are there any other questions?
Yes, sir.
Yes, please.
Back at problem 10. It's not really a question, but
is that Jing?
Question 10.
Yeah.
I wanted to ask if you actually drew up your own equation then solved it simultaneously.
Okay, we'll get back to that. Question 10 and
okay.
10, 16, and 20 are the queries.
Okay, thank you.
And we'll come back to that. Okay, I'm going to stop question time now because it means we have to go through 8 questions and I don't want to hold you up. Okay, so please mute yourselves and we will now go to problem 22 or 21, problem 21. Now in this problem here, they say the 3 carpets have a combined area of 200 square meters. By overlapping the 3 carpets to cover a total floor area of 140 square meters. The area which is covered by exactly 2 layers of carpet is 24 square meters. Which area of floor is covered by exactly 3 layers of carpets? So I'm going to go to my diagram. All right. I'm drawing the 3 carpets here. And there's a question. Let's go through this thing slowly. 3 carpets have a combined area of 200 meters. Now, they are overlapping, one on top of the other. You can imagine it. So, some of them are 2 carpets thick. Some of them are just 1 carpet thick. Like these are 1 carpet. There's only one here, P. I'm naming these little areas. These are all areas. This part here is P square units, A square units, and so on. All these are areas. I'm naming this area here as P, naming this area here as Q, and so on. So you got quite a few unknowns here. It's 7 of them. Now, what we do know is that the combined area of these carpets is 200 square meters. In other words, when I take this area of each carpet and add them up, the answer is going to be 200. Just bear that in mind. That's the first fact. Maybe we can write it down here. But it's going to be a complicated thing because you've got all these, the 4 numbers here, plus these 4 numbers, plus these 4 numbers, 12 numbers altogether gives you 200. Just bear that in mind, right? And it also says that the 3 carpets, by overlapping the 3 carpets to cover a total area of 140 square meters. So that means this part here, when you're overlapping, this area here is covered by these overlapping carpets is 140. So it means that P plus A plus Q plus B plus X plus C plus R, the sum of these 7 numbers is 140. But the sum of 12 numbers is 200. Just bear that in mind, right? Because each carpet has got 4 numbers associated with it. So the sum of 12 numbers is 200. The sum of 7 numbers is 140. Now the area which is covered by 2 layers, now which parts are covered by 2 layers? This part here, only 2 layers. This part here also, 2 layers, and this part. The area that is covered by 2 layers is 24. Right. So what I've done here is to simplify the problem. There are too many unknowns. I've given new names to these unknowns. And this 3-layer area, I'm calling it X, because that's the question. What area of floor is covered by exactly 3 layers of carpet? So this is what we need to find. So that's your unknown, right? And I give, this is your 3 layers, and the 2 layers, A, B, and C, I give that a name. Can you see? I've given the name Y. Y is A plus B plus C, right? And that we know to be 24, so Y equal 24, right? And the carpets which are covered by 1 layer, P, Q, and R, right? The area covered by only 1 carpet, we give that a name as well. So P plus Q plus R is given the name Z, A plus B plus C is given the name Y, and this is X. So I got 3 unknowns rather than 7 unknowns. Now, let's have a look at the given information. Firstly, the 3 carpets have a combined area of 200 meters. I'm going to hold on with that, but I'm going to say first, by overlapping the carpets to cover a total area. So this area is 140, this entire area here. So there's an equation here, namely X plus that part which is covered by 1 carpet, which is Y, which is covered by 2 carpets. X is 3 carpets, by 2 carpets is Y, and then by 1 carpet is Z. That area is 140. And now we made the problem very much easier because we only got 3 unknowns rather than all these. We classify those which are covered by 1 and 2 and 3. But we know that Y is 24, because Y is the area covered by the total area covered by the two carpets. So this thing here is 24. So that gives you an equation, X plus Z equals 140 minus 24, which is 116. So now I've got one equation with 2 unknowns. So that looks very good. Okay. Now let's go back to the first information. We've used this information. We use that information. There's only one thing which we haven't used, and that one. And that is the 3 carpets have a combined area of 200 square meters. Right. Now, this is where you've got 4 numbers plus another 4 numbers plus another 4 numbers. Right. Now watch. The X is added to itself 3 times in the combined area. Because when you separate these and you put APXC, 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 you see X, X is occurring in all the 3. So there'll be 3 of those X's. And the A's, each one of them occurs twice because this covers 2 carpets. This A is counted twice. It's counted here for this carpet and that carpet. So the 2 carpets will be counted twice, each of those spaces there. And the 1 carpet space, PQR, is counted once. And that is called Z. And that area is 200. Now, if you didn't understand that, maybe you can see like this now. You see, there are 3 of these. And here, you got 6 of these because you got A, B, and C all doubled up. So 6 of these, that gives you 9, and there are 3 of these. So that gives you 12. That's how you get the whole thing. So you got, now Y is already known. Y is 24. So you got these equations. X plus Z equals 116. And Y is 24. So if you substitute Y equals 24 in that last equation, 24, that gives you 48. You bring that 48 to the other side, you get 152. Now you have only 2 equations and 2 unknowns, and that you can solve for X, right? I'm just going to do it mentally, and the answer is 18. Okay, so this is a tricky problem, but it's a problem which requires a lot of thought. And if you rename this the way we have done it, classify all those parts which cover 1 carpet and those which cover 2 and those 3, then the problem gets greatly simplified and the equations come out very quickly. Okay, so that's problem number 21. Problem number 22. Okay, so here you got a practical problem. Teams A and B are playing a series of games against each other. The probability that either team to win any game are equal. In other words, think of soccer, right? Both the teams are just as strong. There's no guarantee that any one of them is going to win. They've got equal chances. Okay. Either team A must win 2 games or team B must win 3 games to win the series. So A is starting off, on the right foot because it's got a better chance of winning the series. B must win 3 games to win the series. Now, what they don't say here is that once a team wins 2 games, then everything is called, the game stops. There are no more games after that. Okay. So if the probability of team A winning the series is expressed in the simplest y, x over y, and so on. Okay, the question is now, what is the probability of team A winning the series? That really is the question. Okay, so I've got a blank page here. The question is now, what is the probability that team A, remember A, if it wins 2 games, A needs to win only 2 games, and B needs to win 3 games. And okay, now they start playing. We're going to write down game 1, game 2, game 3, game 4, and so on, and see what goes on in each game. Either A or B wins, right? So I'm going to work out all the possibilities. So let's say game 1, A wins. All right, so A wins. So what happens to game 2? Well, you could have either A wins or B wins, right? If A wins, everything stops. because A has won the series. A has got 2 wins. It has won the first game and the second game. But if B wins the second game, you still need to go on. You could have here, you could have either ABA or ABB. The third game, either A or B wins. Right? At this stage here, you will stop. Because A has won 2 games. But as far as this is concerned, you will continue. The fourth game, either A wins or B wins. Right? And in this case here, this you stop there and you'll also stop here, because this time B, you got 3 Bs, you see. Right? If you got 2 A's or 3 B's, then you stop. Right? Now this takes care of where all the cases where A wins game 1. So suppose now you take B wins game 1. I hope you understand that we have taken care of all the cases where either A wins the second game or B wins the second game. I've taken care of all of those things. And now you got B wins game 1. So what happened to the second game? You're going to have, well, let's do it here. B wins the first game, so you can have BA. It doesn't stop there, right? Or you can have, from here, you can have BAA or BAB. The third game, either A or B wins, there you will stop, right? Now, at this stage here, BAB, you can't stop because you still have to carry on to see who's going to win. So you can have the fourth game is either BAB, like that. The fourth game, either A wins or B wins. Here you'll stop there and you'll stop there. Right? So those are the, I'm putting ticks at where you stop the games. Right? I didn't put a tick there because you don't stop there. All right. Now that is where you have BA, but we didn't have BB yet. Now BB, you can have either BBA or BBB. Here you'll stop. B wins all 3 games in a row and wins the series. But here you don't stop. So here you will have to go as BB, the fourth game, either A wins or B wins. Right? In this case here, A, you stop here, and here again you stop there. Right. So that is if B wins the second game. But it's so if B wins the first game, A wins the second game, we finished it, and if B wins the second game, we finish that as well. So now you can calculate how many times does A win. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, 4, 7, 11. 11 cases. In some of them A wins and some of them B wins. Right. Out of those 11 situations, how many of them were won by A? 2 A's, 2 A's, 2 A's, 2 A's, 2 A's, 2 A's. That's all. So you get 1, 2, 3, 4, 5, 6. So 6 out of 11 chances. So the probability that A will win is 6 out of 11. Please check this thing out Because every time I work this thing out, I get different answers. But you have the idea to see how to solve this problem. And the question here is, what is the probability? If you go back to the question, which I didn't read fully, they said, what is the probability? If the probability of team winning the series is X over Y, and we just saw the probability is the 11 times where the game finishes, and of those games, 6 times A wins the series out of 11. So the probability is 6 over 11. And calculate the value of X plus Y. So the answer is 17. Okay. Okay, you can see the problems are getting more and more demanding as time goes on, because round 3, you see, they choose only 100 students out of almost 6,000 or 7,000 students. So most of the people wouldn't come to these higher level questions, but in our case, it's well worth going and doing all that, because some of you may very well get to these higher level questions. Okay, problem number 23. Right? It says YE and M times ME is triple T. So this is a 2-digit number which ends in E. It's a 2-digit number which ends in E. And this is a 3-digit number where all the numbers are T. And they say each of the letters represents a different digit and 0 is included. Right? And the digits are the 9, 10 digits, which could be anyone from 1 to 9 or 0. Right? But this is a product of 2-digit numbers. So what are these values? The answer is very easy. I'll tell you how you do this, because this number here, TTT, has got all the numbers are the same. Right? 555, 444. So this is really 111 multiplied by T. If you take the T digit out, the digit T out, 666, 6 times 111, 888. So now 111 is 37 times 3. This is 3 goes into this, 37 times. So this is 37 times 3T. And that is equal to YE times ME. So you can see that one of them has to be, T is a single digit, one of them has to be 7. Right? So the E value is 7. The moment you got the E value, you know that this is also 7. So you got 2 numbers which end in 7. And when you multiply them, the number will end in 9. So you got these 2 numbers. They both end in 7. When you multiply them, ends in 9. So the value of T is 9. And this is 37. This ends in 7. It turns out that this is actually 27. So you can solve this problem immediately. Just a single equation with 4 unknowns. But you can see by factorization, you see. And you can find out exactly what these symbols are. And they ask you to work out the sum of the 4 symbols. And after that, it's just a routine, which I'm not going to do. The 24th problem is a geometry problem. I don't think I'm going to do this. Maybe I'll do this next week. But I want you guys to try it out. It's a difficult problem. I usually give you very challenging problems. The problem number 24 and problem number 25. These 2 are quite challenging problems. I think I'll just leave those 2 things out for the time being. And maybe in the last session, maybe we will do that. It may very well be that I'll just do 3 years and not the whole 4 years, so that we can set aside the last session for the difficult problems, the very difficult problems, because it is taking too long to finish all these in 2 hours. So I'm going to stop there. Okay, problems 24 and 25, I'm going to delay it maybe to the last session. And so that is where we will stop. Okay, and I'm going to, at this stage here, I'm going to stop recording as well.
Okay, sir.
Okay, let me just stop the recording.